As we saw in the first Snowflake DAG of tasks video, task hierarchies provide powerful processing workflow functionality using simple declarative syntax. This video is a walkthrough of a design being used to extend the custom SnowLoad framework using a DAG of tasks workflow. In another set of videos, I described an infrastructure for automating a Snowflake ingestion and enrichment process which I've named SnowLoad. SnowLoad is a data-driven solution for generating Snowflake code objects for use in updating fact and dimension tables in a Snowflake database. The default workflow in the SnowLoad framework is for source data files to be ingested into staging tables for immediate input to transformation processing into historical fact and Type 2 slowly changing dimension tables. While this straight-through processing design makes source inputs quickly available in historical tables, downstream consumers are exposed to the effect of in-process updates, and there is no concept of a consistent post-update cycle distribution source. An alternative to the standard SnowLoad workflow uses a Snowflake DAG of tasks to separate source data file ingestion from transformation and distribution. First, source data files are ingested as they become available into staging schema tables. This ingestion processing is identical to the file ingestion used in the straight-through model. However, in this design, transformation tasks are not immediately executed based on the staging data streams having new data. Instead, transformation processing begins when all new source system files have been ingested for the current staging cycle. A refresh trigger file is created which activates a root task that is the parent for a series of processes to update all transformation tables in parallel. When all transformation tasks have successfully completed, the transformation schema is cloned to provide a consistent post-update view of the reporting data. The process for generating and executing the Snowflake objects for ingestion is detailed in another series of videos, so we'll start with the triggering of the transform schema refresh processing. Using Snowflake scripting similar to the basic example in the first video, a three-level DAG of tasks hierarchy has been created for the refresh processing. The root task, TA transform refresh, is initiated via a stream trigger, in the same way standard transform processing is initiated in the SnowLoad architecture. The stored procedure handler for TA transform refresh, SP transform refresh, performs some cleanup operations. When it completes, the second-level tasks in the hierarchy, which are all of the individual transform processing tasks, in this case the two calls to SP transform entity merge for entities testFact2 and testFact2a, automatically start in parallel. When these tasks complete, task TA clone schema transform starts. Its handler, SP clone SC transform, performs a schema clone on the updated SV transform schema. In the SnowLoad architecture, all procedures output log detail to the tlog table. We can run a query to review summary log output for the most recent refresh run. The output of this query displays the first and last log output entry for each stored procedure execution from the most recent refresh cycle, in the order the log entries were written. SP transform refresh, the two calls to SP transform entity merged and SP clone SC transform are invoked by the task hierarchy. The other procedures are initiated within these three stored procedure calls. SP transform refresh, the handler for root task TA transform refresh, simply deletes the cloud file used to trigger the refresh process and clears the stream created by the table updated by the pipe ingestion of this file. This prevents further executions of the refresh process until a new file is dropped into the cloud source location. On completion of SC transform refresh and TA transform refresh, both of its dependent tasks, TA transform testFact2 and TA transform testFact2a, automatically initiate, calling transform wrapper procedure SP transform entity merged. each run passing the transform entity to be processed, in this case, testfact2 and testfact2a. The SnowLoad infrastructure has two transform wrapper procedures. The standard procedure, SP transform entity, processes staged input batches one by one, starting with the oldest. This is necessary when input batches must be processed in date order to prevent backleveling source data. For entities where source input batches can be transformed in parallel without concern for sequencing, wrapper procedure SP transfer entity merged is used. This procedure merges all source batches which haven't yet been transformed together into one large transform input. This maximizes Snowflake parallel processing capabilities and provides faster throughput than the individual batch processing approach. After identifying unprocessed batches and merging them, SP transform entity merge calls the appropriate transform procedure, passing it the path of the merged data. This is part of one of the called transform procedures. These procedures have the specific logic necessary to update a target transform table from the source staging tables. Note the use of the Snowflake swap command, which is used in this case to swap a temporary copy of the updated transform data with the permanent table in the transform schema. As each transform procedure completes, control returns to the calling SP transform entity merge procedure. In its finally block, immediately before completing, SP transform entity merge calls procedure SP execute task delete staging batch. SP execute task staging batch creates and immediately executes an asynchronous task to delete the temporary merged data created by SP transform entity merged, which is no longer needed. Once all of the second level tasks in the hierarchy, in this case, TA transform testfact2 and TA transform testfact2a, have successfully completed, their child task, TA clone schema transform executes. The handler is stored procedure SP clone SE transform. SP clone SE transform creates a zero copy clone of the updated SE transform schema. And that completes the transform refresh process. In this Snowflake query, we're only looking at a summary of the application log entries with the first and last message log output for each procedure. As we did with the sample task hierarchy in the first video, we can also look at all of the log detail from the task handler processing. As you can see, under the covers, there's a lot of processing taking place, but the entire workflow is managed by a simple declarative Snowflake DAG of tasks.